basketball. He was sitting on the bench eating a hot dog. Yeah. That was pretty fun. That was fun.
Legendary.
Bro knew he's not gonna eat it again.
Alright. So what's the graph of y equals x look like?
Diagonal.
Yeah, it looks like a line, right? Kind of like this. It would be a diagonal, yes. What's the graph of y equals x squared look like? Parabola. Yeah, looks like a parabola. Okay, might not know this one. What's y equals, I gotta change it a little bit. X cubed minus 2x squared. What's the next one? What shape would that look like?
Is that the squiggly thing?
Okay, it's gonna look something like
Weird ass.
this. Well, we did that last year, didn't we?
Yeah.
Yeah. Okay, and then what would an x to the fourth function look like?
More.
Blah, blah, blah.
More of a squiggle.
Like W.
Looks kind of like a W. And how about x to the fifth? Maybe I'll do one more. How about x to the fifth?
It's gonna look like the third, but longer.
It's gonna, yeah, odds start from the bottom, go, and then
Right.
going up.
Yeah. So each time you add a power, it adds another turn, another curve. That's the pattern. So let's zoom out here. I don't know if this will show up on video. So the even powers like 2 and 4, they start up and end up. Or 6 would start up and end up. 6 would just be that. And the odd powers, like x to the third, be called a degree. The odd degrees start down and end up. Okay, but what happens if I throw a negative in front of the x cubed? Or the x to the fourth?
This, right? Like just flip.
It goes upside down. So yeah, instead of starting down and ending up, it would start up and end down. It's basically because the x cubed is the most powerful of all these terms. And if you put a negative in a cubic function, it comes out negative. But if you add a negative in front, it'll be positive every time. So as you go to the negative, it turns positive. Anyways, yeah, I guess you guys kind of remembered that, huh? I'm forgetting something before I move on. What am I forgetting?
How many numbers are
Let me see if the book reminds me. Oh, I remember.
Here. Do it. Stop.
Charlie doesn't have Leo to analyze for his resorting views.
I would drink Leo's water right now. Never.
Okay, what would the zeros of this function be?
3, -1.
3, -1. That's the values that make the function equal to 0. So when x is 3, the function value is 0. When x is -1, function value is 0. Those are also the x-intercepts, 3, 0, -1, 0. So what shape will this take?
Parabola.
Right. If we foiled it, it'd just be an x squared something, right? So it's quadratic, it's a parabola. So it'd be something like this. What happens though if we have like y equals x minus 3 squared? Well, what's the zero of the function? 3. So 3, when x is 3, the y value is 0, would still be the 0 of the function, but there's only 1. I mean, it kind of happens twice. You could think of this as x minus 3, x minus 3. It's called a double root. At double roots, what's going to happen is it's just gonna come and kind of turn at that point. So it just hits the x-axis and it's tangent to the x-axis, you could say. And then just kind of turns and goes the other direction. So it only hits once. Okay? It's possible to have no zeros. If it was floating up here, it wouldn't have any x-intercepts. So, what would this function look like? So what kind of function is this? Is it a linear? Is it quadratic? Is it a cubic function? Or,
Is it a cubic?
yes. Why is it going to be a cubic function?
You have the squares and then you have another.
Yeah, if we FOIL this together, x plus 2 times x plus 2, we get x squared, blah, blah, blah. And then we multiply by another x, we get x cubed, blah, blah, blah. So this is a cubic function. There's basically 3 x's that will be multiplied together. So what shape should it take?
Squiggly.
Squiggly. What are the zeros of the function?
3, -2.
3 and -2. Okay, but the -2 is a double root. So when it comes up at -2, it's just going to get tangent and then go back down. Do you guys know how we would find where it's the y-axis? What do we know for sure about this point?
Just 0.
What's its x-coordinate? 0. So if that means if we plug in 0 for x, that would tell us what it is. It'd be -3 times 2 squared. So it'd be like -12. You guys see where I got that? If you plug in 0 there, you get -3. 0 there, you get 2, but it's squared. And that multiplies to -12. Okay. Did we do all of this last year? Or
Well,
just
not
some?
that last part.
Not this part. Not this,
No.
or not this?
Why?
Yes.
You never did the y.
Not like finding the y part.
Okay.
Mm-hmm.
All right. There is one more thing.
Just in 12.
Okay. So we had the double root, like -2 was a double root. This is a triple root at 1. So triple roots, so normally this would be a cubic function. If we did x times 1 times x times 1 times x times 1, we'd get x cubed, blah, 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 something. So normally it would look like this. But with a triple root, instead of going like that, it kind of just morphs. So here's the root. It would come up like this, get flat right at that root, and then keep on going through. So it doesn't really look like this. It's kind of gets completely flat right there and just keeps going. And if I plugged in 0, I get -1 on that one. So, all right,
Okay.
we're ready.
How many numbers were we on?
And it's a mystery. We'll see how it goes.
Wow. I don't like
32.
Yeah.
Are you happy now? Do you feel happy?
We're gonna need graph paper.
Well, we don't really need graph paper for this.
No?
Nah.
And yourself.
Yeah, okay, fine.
Need
You guys
graph
can.
paper.
You don't really need it, but that's okay. You
I
can
want
pass
it.
it. Sam needs it.
Thank you.
Oh, I thought you were gonna pass it around.
Nah.
Oh, shoot, I thought you said only.
You said you didn't need it.
For those watching at home, you don't have that one. tear it.
He tried to give me a paper that was all crumpled.
I would never do that to you, so.
Alright, so we're supposed to sketch this. I'm not gonna make you guys find the y-intercept except for maybe, let's do it like on 1 through 4. Just so you guys know how to do it, but I'm not gonna worry about it that too much. Okay, number 1. Yuck.
Yeesh.
Yuck.
About as skinny as Trey.
You really
The
good
tray
at that?
one.
Thanks, Ashley.
So sweet.
Okay, so what kind of function is it gonna be? Okay, it's a cubic function, x, 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 so it's gonna be one of these things. So what are the zeros of the function?
-1, 2, 4.
So we'll just put dots right there. And how do we find the y-intercept?
Plug in 0.
0 for x. So if you plug in 0, you get 1, -2, -4. What's 1 times -2 times -4?
So 1.
I don't know if I can go that high.
-8.
Positive 8.
What was the numbers?
If you plug in 0, you should get 8.
My bad. I did positive to negative.
Silly as that.
Silly.
Silly.
And so just those points, that'll work. Oh gosh. Turned the radio on in the car this morning. Could not get that stupid song in my head.
Which song is it?
What song?
He says watermelon sugar high like 50 times. He doesn't change the lyrics like once. I don't think there's any verse. There's just that over and over.
Trey, were you listening to
song.
Harry Styles?
Do you like Harry Styles?
Is that Harry Styles?
Yes.
Why am I shouldn't?
Sam, shut up.
Don't do it. Don't you dare. Alright, number 3 is a what kind of function?
The try, what is it?
Cubic.
It's cubic again. But the negative's gonna do what to it?
Flip it.
So instead of down to up, it's gonna be up to down. What are the zeros of the function gonna be?
0.
0,
-5.
-5,
-3.
-3. So it's all to the left. Okay, I guess we don't have to find the y-intercept on this one. You guys know why?
Because it doesn't really touch it. Oh, no, it touches it at 0.
Touches at 0, 0. So we already got the y-intercept. Okay, number 5, what kind of function will that be? X cubed is a cubic function. What are the zeros?
0, -2.
0 though is a what?
Double
Double root. So it's a cubic function, so we're still using this. But 0 is a double root, so that means it's got to bounce when it hits 0. Like so.
Don't you just love that song must be good?
I prefer some variation. Okay, what's number 7 gonna be?
Next to the 4th.
Yeah, it's quartic, I'm not gonna make you guys memorize that. Quartic, that comes after cubic. I guess a 5 would be a quintic, but I've never heard that said before. Okay, what are the roots?
0, 1, -1, and -2.
Yeah. 0, 1, -1, -2. So it's very tightly packed. What shape did a quartic function take? W. So starting high, ending high. This will be a very squiggly W. Should be more, right. What's the degree for number 9 going to be? Quartic again. It's got x to the 4th on the front term and another x, so that's 4 x's, so it'll be another w. What are the roots? -1 and 2. But -1 is a triple root. So what's going to happen?
It goes completely flat.
Okay, it goes flat,
And then
goes through, and length of bounds. So it's like a really lopsided W. I wonder what's the Y value? -2. Oh, yeah, it's not too bad. Make it ugly. Hey, I got a new song in my head. Victory.
Stop.
So I'm making my way back to you. Okay, number 11. What's the degree on 11? 5. So what's a 5 look like? Kind of like a 3, but with another hump. So
Hey,
double humped camel.
Jordan. What do you call a 3-humped camel?
What?
Pregnant.
Wow. I thought we couldn't go below the circumference.
that was honestly worse than the sandwich.
I was wrong.
That was weak.
Okay, 11. What are the roots?
0, -2, 1, and -1.
Oh boy. Zero, -2, -1. But 0 is a double root. So here's my, double hump camel. 0 is a double root, so very odd.
Oh. We just go to 12 to Good point.
Let's go. Mm.
12.
I believe in you people. I think we can go to 18.
God.
You don't want the challenge of 17 and 18?
No.
Okay,
It's not
well,
16.
the only difference is they didn't factor it for us. So how do we factor number 13?
Take an X out.
Take an x out. Take an x out, you get x squared minus 4. Now what?
And factor out.
This is a square minus square, so what's that turn into?
X minus 2, X plus 2.
Okay, so the roots,
Do they always turn to square bunch of squares?
No.
Or do some not factor?
they all factor.
Alright.
It says factor each polynomial function and sketch the graph.
Sure, why don't you use your brain? Oh wait, Leo must have the brain
I
cell.
didn't think about that.
I forgot to bring the brain cell
You
this
forgot,
morning.
you forgot to bring the brain cell.
Okay, so it's 0 to a negative 2, and what shape should it make?
The normal one.
Yeah,
Yeah.
you can't just scratch on your desk, that doesn't count. Yeah. What would I need? Just for one moment. Floating away. 15. Some of you guys are out of room, are you? Did you pull Leo?
Leaving room for.
Huh?
Does anyone else need
I'm gonna need one. Half one. Half.
How?
How, bro?
Because I'm leaving room for.
The evens.
Yeah.
Oh, I am too, and I'm just writing some of the actual equation on the paper.
I just reluctantly grabbed paper, but
Punch you.
that works too.
Okay, how can we factor 15?
Taking X squared out.
Taking x squared out. A lot of people do this wrong when they, something like this. What would be left if we take an x squared out?
Only x squared minus
1.
quant.
Because we're dividing x squared out. That's what I mean by take it out. X squared divided by x squared is 1. What's the parentheses going to factor to?
X plus 1, X minus 1.
This one.
Okay, so the roots are 0, negative 1, 1.
So freak out.
It's,
Just put duct tape over his mouth every time.
it's an quartic x to the 4th function, so that means W shape, but what?
So weird. This
0 is a double root, so it should bounce when it gets to 0. Okay, so 17 and 18 both normally should have 4 roots. They're telling us that 1 on 17, 1 is a triple root. How do I find the remaining root?
Plug in.
No. So it's kind of like what we did at the end of yesterday. I'm going to divide, if 1 is a root, that means x minus 1 must be a factor. So I'm going to divide by x minus 1 3 times to leave me with the remaining factor. You guys remember yesterday? Get dramatic over there. 1, negative 2, 0. So I'm going to divide by x minus 1 by putting 1 in the box 3 times in a row. If I do it right, my remainder should be 0, because I know this has to be a root. That's a negative 1. Did I copy everything else right? Yeah, okay. Here we go. Wait. represents like a x to the third, blah, 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 but doesn't matter. I'm just gonna divide by x minus 1 again by putting 1 in the box.
I'm so confused.
Still outside.
And I'm gonna divide by x minus 1 again.
Are you just doing it 3 times because it's triple root?
Yeah, so basically they're telling us that if 1 is a triple root, then x minus 1 is a triple factor. And there's another mystery factor that would multiply. So if we divide by x minus 1 3 times, it'll leave me with the missing thing.
So you just do that with 3 on 18.
When you do it twice, it says it's a double root.
Oh, is it a double root?
Yeah.
So if it's a double root,
That's 10.
that's like what we did yesterday. So you do it twice, and then you'll be left with an x squared thing that you can factor, just like yesterday's. Okay, so this is, what's 1 and 1? What's that stand for?
Square in it.
No, that's 1x plus 1. So that's the mystery factor. So I got a triple root at 1 and a normal root at -1. What shape does a quartic take?
W.
W. This will be a funky W. You kind of already had a funky W. Triple roots. Bam. Let me try it again. Get flat and go. Shoot, I just realized we did 7 wrong.
Why'd you do that?
Why? Mr. Jordan.
7 we did upside down because there's a negative in front of one of those x's, so if you multiplied all those together, it would be a negative x to the 4th. We'll just leave it though. On, let's see, I'm looking at the evens now to make sure, see if there's any over there. On 10, will that be normal or upside down?
Normal?
Upside down.
Yeah, that first negative is not being squared. So that's like 1 negative. And then the second negative x is being squared. So that's like 3 negatives. So it will be negative. So number 10 should be upside down. No, number 12, that negative x is going to be squared. So it'll be right side up still. So just 10 is upside down, looks like.
Get it.
Well, 2 is upside down, but that's because they put the negative out in front.
Which ones do you want us to put the y-intercept on?
Let's do 2 and 4, find the y-intercept. On 2, don't forget there's a negative out in front.